Hello, my name is Avinash Bhat, and I am a graduate student at McGill University, Canada. I'm presenting our work on investigating the effectiveness of the current practices in documenting ML models and introducing a potential tool to support documentation during model development. A large number of pre trained machine learning models are hosted and shared publicly using GitHub or model hosting sites like Hugging Face. However, most of these models are either poorly documented or not documented at all, resulting in unanswered questions about their intended use cases, performance during adoption, and ethical and social impacts. Here's an example of one such model that has been downloaded about 8 million times last month from Hugging Face, but only contains a brief description, citation information, and license. These models are often reused in various software systems, leading to serious misuse related issues. To counter the issues, there have been notable efforts towards documenting ML models, among which the proposal of model cards is the most influential. Model cards are short documents that accompany the trained and hosted models and provide details about the context in which models are intended to be used and other relevant information. The model card proposal suggests 9 sections when documenting ML models, including information on the intended use, ethical consideration, along with technical aspects like the data used for training, evaluation, and measurement of performance. They are essential for promoting transparency and accountability in developing and deploying machine learning models and ensuring that the models are used responsibly and ethically. So far, model cards are increasingly being adopted by different parties. For example, Hugging Face, the most popular ML model hosting site, has made model cards the default way to access information about the hosted model. It further provides training materials and web tools to support the model developers in writing documentation in the form of model cards. However, it is unknown how the model card proposal and corresponding efforts in promoting its adoption have impacted the ML model documentation process in practice. To reliably evaluate the conformation towards model cards in the wild, we converted each aspect mentioned in the original model card proposal to a yes or no question in our evaluation rubric. We curated a dataset of 132 model cards from Hugging Face, GitHub, and company websites. Then, we used a rubric to analyze these model cards to investigate if publicly available model cards contain different aspects of information recommended by the model card proposal. Our analysis indicates that most of the model documentation has an unbalanced coverage of concepts that are outlined in the model card proposal. Only the information about the model type, date and version, intended uses, and target distribution are included in more than half of the model documentation. Across the board, details about when the models are not supposed to be used are only documented in 32% of the model cards. Only 35% of the documentation includes discussion on ethics. Any discussion about the ethical issue mitigation or measurement process are included in only 10% of the documentation, which is alarmingly less. Overall, we see two trends. Most of the model documentation has an unbalanced coverage of concepts outlined in the model card proposal. We also observe that the model cards provided by the companies that trained the model and those in GitHub repositories tend to include more information as outlined by the model card proposal when compared to model cards on Hugging Face. To address the big gap observed between the original model card proposal and the model cards in the wild, we designed a tool called DocML. ML model development involves different stakeholders such as domain experts, data scientists, and software developers. As a starting point, we focus on data scientists considering their critical role in model development. DocML nudges the data scientists to consider and comply with the model card proposal and to support continuous assessment and management of the documentation quality during the model development and not just towards the end. DocML is an extension to Jupyter Lab, the notebook environment most data scientists use. When activated, the documentation panel opens alongside the Jupyter Notebook. The panel is interactive and lets the users edit the suggested sections and their titles, input new sections, and customize the order with the configuration file. We maintain the model card content within the notebook to avoid inconsistent and outdated information. To nudge the data scientist to follow the proposal, we implemented 3 interactions. First, when the users hover the cursor over the title, we show a concise description of the expected content within the section. Second, explicit links to one or more high-quality model card examples are shown next to the title. Third, when the users are exporting the model card for sharing, the tool will perform a lightweight check and inform if any predefined sections are still empty, to encourage the developers to complete any missing sections. To support cross-referencing between model card and source code, we adopt the concept of traceability and let the users link code cells to interactive model card panel. We identify the data science stages such as data cleaning, pre-processing, model training, and evaluation for common libraries like scikit-learn, NumPy, Pandas, and Matplotlib by creating a knowledge base. The knowledge base is used to automatically inject trace links in the form of code comments, which forms a link between the panel and the notebook. In case of any inconsistencies, the user can add specific markdown tags and customize the links. We designed a between-subject controlled experiment in a lab setting to evaluate the extension with 16 participants. Participants were given notebooks with low-quality model cards and were asked to develop and modify the documentation. We observed that the participants with access to DocML considered the scope of the model documentation more broadly and added more information about the problem context and ethical considerations, which is often overlooked in the current public model documentation. When asking feedback on the existing features of DocML, participants mostly agreed or strongly agreed that those features are necessary. Participants generally commented on the importance of having the model card template to structure the documentation during the development. Participants also thought that the navigation functions were effective and suggested having automated solutions to achieve similar functions. The participants in the control group who did not use DocML expressed their frustration when developing and maintaining the documentation for the models. They hope to have tooling support that is available to software developers in the form of JavaDoc or Sphinx. They voiced the need for similar features that are currently offered by DocML, such as documentation templates, automated documentation extraction from notebook, and code documentation trace links. In summary, in our investigation on the adoption of model cards, we discovered that the model cards are rare and often shallow, with mostly low quality and selective information. Based on the insight that the traceability and nudging towards good practices within an IDE can lead to better documentation, we built a documentation tool called DocML. In lab study, we observed that data scientists using DocML show deliberate consideration of model development context and ethical concerns. Our work highlights the opportunities and the requirement for better tooling in the space of model documentation. Thank you.